But I think most of you are already thinking, and I hope this again is a review. You're thinking now, well, wait a minute. When you go to cool the room, when you go to get an air conditioning, it doesn't really only depend upon how big is the floor space. Because you're not cooling just the floor. What you're cooling is all the air that is above the floor. And so another piece of this puzzle is how high is this room? How tall is the ceiling? And so we're talking something that is a little bit more than area. In other words, we're talking about a new quantity. So let me add it to our list. So here's our new quantity. So our new quantity is volume. Now, again, I say new quantity, but I don't think this is really new in the sense that you haven't been exposed to it. I think you do a lot of volume stuff in 5th grade, and so you remember all of that. Let me just put the traditional symbol for volume. It's a capital V. I'll put little lines over the top, because sometimes on a whiteboard it's hard to tell a capital V from a lowercase v. But the lowercase v we're going to say for velocity. Okay, so notice these are both uppercase here. But here's that big question. I am now asking about a whole new physical quantity. I started with something simple with length, but that led to area. Now area led me to volume. And so as I got to this thing called volume, I would then ask, well, how do I calculate it? What's the formula? Now, I know, probably about 5th grade, you learned that the volume of a rectangular room like this is length times width times height. Okay, but what if you've never been told before? And I hope you see the same plan. Let me try to draw a picture of this room. It's kind of hard to draw a three-dimensional room on a whiteboard, but I'm hoping you can kind of see that if this down here is the floor, and the floor has a width and a length, it's this length times width we were just talking about, that's the floor space. But then there is a height to the room. And if you were trying to figure out the volume of this room, if you wanted to know how much air you had to cool, you would do something like this. You would say, okay, what I would have to do is take a box and another box and another box. And as we already talked about, I would get 10 boxes over to here. And if I started making boxes going, what in my drawing would be back into the board, I would have 10 boxes that go that way. And so by the time I stacked 10 boxes across here, with 10 rows of boxes, as you would say, I would now have the area. But how many times would I do this? And so maybe I'll just say add the area every time, and we'll just go a whole floor of boxes, and then we'll put boxes on top of that, then we'll put boxes on top of that, and then boxes on top of that, until we fill up the whole room. And so we would add area, how many times? Well, h times, whatever the height is. And so if we write that repetitive addition as area times height, and then if we remember that area is the length times the width, and we multiply it by height, we get what I will call the common formula that you were probably used to before you walked in today. And I'm going to ask it again. Could you have come up with that formula? Had you have never ever seen the formula for volume, could you have come up with it yourself? And let's keep going with this. Because if I put this in, this would be 10 meters multiplied by 10 meters multiply, and you guys can't see it on camera, I'm sure, but the height of this room is about 4 meters up. So let me just put 4 meters. And doing the same logic that we did before, and realizing we can put this in any order we want, we could go 10 times 10 times 4, that's 400. And then we could go meter times meter times meter, so that's meters cubed. And so we end up with an answer that the volume of this room is 400 cubic meters. And we just did step 3. Now, let me summarize. Did you see steps 1, 2, and now 3? Watch. I'll come back here. What was step 1? A new question. A new question, which in this case is a new quantity called volume. What's step 2? Step 2, we gave it some thought, and we realized this is then the equation. Okay, good. Then what's step 3? Step 3 then is right here. What are the units to measure this new quantity? And so we conclude here that the new quantity is cubic meters. It's a meter times a meter times a meter. And then finally, and maybe the most important one, step 4, what does this actually mean to you? What do you mean by 400 cubic meters? And what that means here is you would take a cubic meter and a cubic meter and a cubic meter, and how many times would you add it together? 400 times. And so I would say the meaning here is, and I can't really get this many into my drawings, but if I were to continue to draw boxes in here and start stacking boxes up on top of one another, across the floor, I would have 10, and then 10 rows of that, so there's 100. And then the next level, I would have another 100, and then another 100, and finally the fourth layer, I would have another 100. So it's 100, 100, 100, 100, it's 400. I'd have 400 boxes in here. And so as I said here at the beginning of this lecture here is, let's use this as an opportunity to focus on, I think, the harder part of this, and this is the metric system. And I want you to see something that you may not have seen before, and particularly, how do I take and translate from verbs or from verbiage into equation? And then, of course, how do I then create another question with the answer and the units that measure it and the formula that goes with it and the meaning behind all that? Those are those 4 steps. New question gives us new quantity. The thinking of that new question leads us to the formula for that question, which leads us to the units for that, which then leads us to what does it mean by those units. And that's really why our system of units is set up the way it is. And like I said, this is a little too much for a 3rd, 4th, 5th, 7th grader, even middle school, maybe the start of high school for an advanced student, but really this is a good way for you guys to make sure you see it. Well, let's see, how am I doing on time here? I think, are we about 35 minutes in? Good. All right, is there a time on the, there? Huh? No? Okay.
Yeah, it's
all right, well, we'll go.
45.
45? All right. So I'll keep that in mind that we're 45 minutes in, and so we got another half hour here. But there's a couple of other neat things. This might be the biggest one here. But let me add to this. In fact, maybe to give myself a little more room, I'm going to take this chart and come all the way over here to the far side and leave this chart going here. And kind of squish up these first 3 that we've already done. And so we started here by saying what is the distance, which we use the symbol D for. That led to area, and that led to volume. And of course, as I said, each of those then led to what are the units needed to measure them and the meaning behind them. But there's probably two more I should mention before we move on to other things here in this chapter. And they're not necessarily an extension of these, but they do fit this idea. And so if you remember earlier on about distance, I was saying if I stood on this side of the room and I moved to this side of the room, I would move 10 meters. Okay. But something else you probably did a lot of in kindergarten, besides, that first day when you show up and the teacher says, here's 3 pieces of paper, I want you to put them in order of biggest to smallest, so the teacher kind of has some idea, do you know about the physical quantity distance, and do you know how to arrange things? But another thing that was probably very apparent was another physical quantity, time. How much time did it take as I moved across the room? Or again, you're sitting there putting those in order, and the teacher is giving you this thing. Okay, we're going to do this for 5 more minutes. And then it'll be snack time, or then it'll be recess time. All right, and so you were learning that there is something else out there. Some other physical quantities that aren't related to length, something totally different. And so let me put that on the board here, a very important physical quantity that you've probably already have spent a lot of studying with, and that is this quantity of time. And let me emphasize, remember everything in this here is a question that is not invented by humans. It is what we in the physical world discovered. And there's this thing called time. And I know often people will say, oh, well, time is a human invention. No, no, no. The measuring device, the watch, the clock, they measure time. But if you take like a year, the definition of a year is the time it takes for the Earth to go all the way around the sun. If there were no humans, there would still be a time it takes for the Earth to go all the way around the sun. And so it's one of what we call these fundamental quantities, like distance. Time is part of nature. It just took a certain amount of time for the Earth to go around the sun. Or it takes a certain amount of time for the solar system to develop. Or it takes a certain amount of time for the universe to expand out to a given size. 13.8 billion years as we know it today. So time is an important one. And if this was a face-to-face class, I would just say, what symbol shall I use for time? Put a T. And the same thing here, since you're familiar with time, I would put, okay, in the metric system, what unit do we use, what base unit, I should say, do we use to measure time? And the answer is a second. And so the metric system and the empirical system, we each use a second. So that's kind of nice. Whereas, the empirical units, we would use things like inches and feet, but metric system, we would do meters. But both systems uses a second. And of course, then I'm going to put an S for second. And so I could do the same thing for this quantity that I did back here for this quantity. I could do this. I could say, all right, I'm on this side of the room, and I'm going to move to this side of the room. Now, let's just say it took me 5 seconds to get from one side of the room to the other. Now, we already know it's a distance of 10 meters. So more on that later. But right now, I would just say then, all right, how would I write on the board? How would I write that the time it took for me to go from one side of the room to the other is 5 seconds? And so I guess it would look like this. I would say the time is, okay, see how I'm changing the vocabulary into an equation? The time it took, the time is, and I would say it took me an S, and another S, and another S, and another S, and another S. Each S stands for a second, right? It took me 5 S's to get across. It took me an S, and an S, and an S. And so in an abbreviated form, I would write that as 5S. And so there it is again, with no comma, no semicolon between the 5 and the S, because again, what do we mean? We literally mean the number 5 times the symbol S. And so this is a sentence. The time is 5 seconds. It took me 5 seconds to go across the room. So we're going to do the same thing with all of our quantities that we talked about here for later. Now, maybe we should do one more here before we wrap up this chart and go to a few other things that in this chapter. But another fun one to think about, and so I'll just pretend I'm going across the room again. So here I am. I'll say it again. If I start on this side of the room, and I move to this side of the room, okay, we said the distance would be 10 meters, okay. The time it would take would be 5 seconds. But another question we might ask is, how much material, how much atoms went from here to here? See, because if I did this with my calculator, the calculator would go from here to here. And so the calculator went 10 meters. The calculator could do it in 10 seconds. But there is something different when I go across the room versus the calculator. And I would say that is the number of atoms, the number of molecules, the amount of material, the matter that goes from one place to another. And so, yes, there is a very important quantity that I'm trying to introduce you, another fundamental quantity. And that would be its mass. And so how much material, how much matter is probably a better word here, how much matter moves across the room. You might even say, how much weight moves across the room, but as you guys will soon see, there is a slight subtlety difference between weight and mass. And so we'll get to that. And I think some of you probably already know that. Usually in a face-to-face class, I pause. Is weight and mass the same? And about half the class goes, I don't know. And the other half of the class goes, oh no, they're not the same. I remember that from my high school or my middle school physics. And so I'll point out that at this stage, I won't make a distinction between mass and weight, but they're not the same. Okay, so we'll just say mass and we'll begin to understand it a little bit more. But here's a really good question for you. What symbol should I use? And this is where I really wish we were in a face-to-face class. Because I usually pause here and I say, okay, what symbol shall I use for mass? And when I do that, I hear some people say, capital M. And I know they're thinking capital M because mass starts with an M. But didn't we already use an M, a lowercase m, for meter? Yes, but wasn't that in a different category? So, to some people's surprise, the answer for the symbol for mass is the lowercase m. We are going to use the lowercase m. Hopefully you won't get it confused because you see how this is in a totally different category? This is a unit, but this is a quantity. maybe this is a silly comparison, but I don't think anybody would have said this. Oh, don't use a lowercase m, because I used that in my English paper last night when I was making a story, or writing a story. And you're like, well, no, you can use the lowercase m in your story. Nobody's going to confuse that lowercase m in your story with this lowercase m for math. Although those are two different classes. All right. These are not different classes, but they are different ideas. These are the units. These are the quantities. And so keeping that in mind, you hopefully will never confuse the two. Okay. So I hate to admit it, but I am about 75 kilograms. And so if I were to move from here to here, oh, that would be my mass. Oh, forgive me, I guess I got too far. Let me come over here. What are the units in the metric system to measure mass? And usually in a face-to-face class, I hear people call out grams or kilograms. Grams is probably a better description, although grams is so small that I see why you're saying kilograms. So more on what we call the prefixes in just a second, but let me call it grams. A penny, by the way, is 3 grams. Give you an idea. And so you should really know how long a second is, which I think you do, and how long a meter is, which I showed you, and you probably already did. But you should also know what about a gram is. So a penny is about 3 grams. And the symbol we're going to use is G. So if I were to tell you my mass, and let me use grams this time, I am about 75,000 grams. So I would put over here, my mass is 75, that's a terrible looking 7. Let me see if I can fix that. 75,000 grams. And again, probably don't need to say much more here, but do you see how I wrote it the same way that I wrote for time, that I wrote earlier for distance? Distance is 10 meters. But I like to put both of these on the board because I think when you see it this, you'll know, isn't it obvious that this M is for mass and this M is for meters? One of the giveaways is the number in front. See, here's the quantity and here's the unit. Here's the quantity, here's the unit. And so hopefully you won't have any troubles with the lowercase m. I say hopefully because I know when you're learning something, even if it has good logical reasoning why, it may not be obvious to you. But I will point out that we do have lowercase m twice. And we're going to have it 3 times before the day's over. But hold on here. All right, so it looks like we're about an hour into the lecture here. I'm keeping track of time. And that's about probably perfect because I'm going to wrap up then this chapter here in just a second. Because as I mentioned, there's a couple of neat things to see in this chapter. And most of them are around this metric system. And like I said, I'm just going to do a review of the metric system. I've also reviewed things like what is the equation for volume and area and the units. And all of these I know you've seen before. But here's what I'm hoping. I'm hoping you have now seen them in a little different and what I would call a more advanced setting. A more advanced light, if you will. Okay, because then there's something else that the metric system does really well. We call this the prefixes. And I think you're familiar with the most common ones. Let me put the common ones here on the board. Maybe the most common one is the centa. I don't know, maybe killa is just as common. Milla is pretty common too. Maybe less common is micro, or even less common is mega. But let's talk about the prefixes. There are others. These are the, what do I have, 5 here that I'm going to ask you to memorize. These are the 5 that are the most common 5. That's probably worth memorizing. But as you look at chapter 1, you will see a big table that has a lot of other ones. You don't need to memorize all those other ones, but know that they're there. And so as we go along through the semester, you may come back, because we may see something like giga or pico and go, oh, what pico? What does pico mean? And I'm not asking you then to memorize it, but I am asking you to go, oh, wait, that's a prefix. It's back in chapter 1. Let me go back and look at it. All right, but these are so common, they're worth memorizing. And here's why we call them prefixes. Because I think you've seen, how about this word before? If I put this word on the board here, centimeter, or millimeter, or kilometer, usually pronounced kilometer in this country. What do I mean by all that? And let me begin with the prefix. Did you catch that all of these were put in front of the root word meter? Okay? And so I'll change colors here and point out that if you don't see it, notice that all 3 of these have the word meter in it. They just have a different prefix. I could do the same thing with a gram. I could go centigram, milligram, kilogram. And again, just in case you don't see it, notice that everyone has the root word gram in it. And what's nice about this, and I tried to pick the most common ones that I think you've heard before, things like milligram, kilogram, millimeter, centimeter, is that if I came across something that maybe I'm not familiar with, like a megameter or a megagram, do you see the root word in there? Could you tell me what this measures? You see everything up here with the root word meters measures, and if this was face to face, usually people yell out, measures distance. Exactly. And so even if you had never, ever, ever seen this word before, megameter, the fact that it has the root word meter would tell you right away that this measures length. End of story. It measures length. Sure enough. And the same thing with the second row. The second row, if you'll notice, everything has grams in it. And even a word that I've never heard before, like megagram. I know that all of these measure mass. Exactly. Because they all have gram in them. Now, they are different sizes. And what I mean by that is just like an inch is different from a foot, and a foot is different from a yard, all of these which measure length are different. And they're different in their size by whatever the meaning is of their prefix. And so let's come back to our prefix. If you don't already know, this is what I want to commit you to commit to memory. What does the word centa, the prefix centa, actually mean? And it means 100th, which if you'll let me write it as 10 to the minus 2. What does the word kilo mean? It means 1,000, which if you'll let me, I'll write it as 10 cubed. What does milli mean? 1,000th, which I will write as 10 to the minus 3. Okay, so what this is saying is this, because it has the word meter, means that it measures a length called a meter. And then the number in front, and I'll just kind of spell it out here, means 100th of a meter. So if I were to pick up this meter stick again, this whole thing is 1 meter. And if I turn it this way, and I don't know if the camera will pick up the smaller ones, turn it over here, but they are numbered from 1 to 100 here. And each of those, and I'll just maybe look here from 80 to 81, that is 100th of a meter. So these are centimeters. These numbers, 80, 81, 82, 83, 84, these are centimeters. Each of those is 100th of a meter. Now, look at here. What this would mean is 1,000th of a meter. And see, the only thing I need to know is the meaning of the prefix and the root word, and I can put them together. And so, even if you'd never heard the word millimeter or centimeter, but I know you have, that's why I said this is a review. But if you'd never, ever seen this word before, you could have just looked at this and said, hey, this measures length, and I know about how big it is because it's 100th of a meter. This also measures length, and I know how big it is because it measures 1,000th of a meter. And then this one here also measures length, and it measures a pretty good size length because it's a kilo, and kilo means 1,000, so there's 1,000 of these guys. And so that's a long length. And so I have an idea what these are, even if I've never seen them before. But again, I know you have, but I want to make sure you see it. In fact, I'll even go one more step here, because there's usually a symbol given for centa. It's the symbol C. So instead of writing it in its full form as centimeter, or even writing it as 100th of a meter, we could write it as cm. Now let me pause right there, because I think all of you have written the word centimeter many times before. You know, maybe you took this pen and you put it on a ruler and you would say something like, hey, this pen right here is 14 centimeters. And you would write cm for centimeters. But that's what I want to caution you. cm does not stand for centimeters. Did you catch that? I'm going to say it again. cm does not stand for centimeters. It's C for centa times m for meter. See, because what if I were to ask you to convert this into meters? You would say, well, this is a 14, and this is really a C times an M, and a C is really 100th of a meter, and 14 times 100 is 0.14 meters. Did you catch that? See, the C and M don't go together. I can separate them. It is the number C times M. cm. So C for centa, M for meter. So I'll say it one more time. cm does not stand for centimeter. It's C for centa, M for meters, and we're multiplying them together. And then once you realize that, it's what makes converting it from centimeters to meters actually pretty easy. Let me try it again. Well, what would be then the symbol here for a millimeter? Yeah, let me come back over to here. We said a millimeter means a thousandth, but the symbol we like to use is, there it is again, lowercase m. Now let me jump way over here. We can get ourselves confused. We have a lowercase m for meter, we have a lowercase m for mass, and now we have a different category. We have prefixes. So even though this is a lowercase m, please note it's a prefix. And so hopefully this m for milli and those other m's you will never confuse. Obviously you could, but it's okay to use a lowercase m here because we have not used a lowercase m for milli or for any of the prefixes yet. And we're going to use it for milli, excuse me. So with that in mind, I would say that a good symbol here for millimeter is m times m. And so again, if I were to come over here and measure, hey, what's the width of this pencil or marker? So maybe I would come over here and I'd say, okay, well, the width is 19 millimeters. And so I would say 19 millimeters. And let me just play the same game. I did not put mm for millimeters. Mm does not stand for millimeters. What does the first m stand for? Milli times meter. Those are separate. And that's then why I'm sure you've seen over and over in your lifetime mm for millimeter.